In the previous videos, part 1, 2 and 3, we discussed that we need to have drafts at forward perpendicular, aft perpendicular and mid length of that so that we can find the draft at center of a flotation. The draft at center of flotation is hydrostatic draft. So first we need to find the mean draft, and we also discussed how to apply correction to obtain draft at forward perpendicular, aft perpendicular and the mid length, and this is the mid length. We also know that center of flotation is the point about which a ship trims. So here this is the center of flotation and this is the draft as center of flotation. So the draft at center of flotation is different than the draft at mid length, and we need to apply this correction, and this is the correction because of the trim. Well, if this is the water line, so this is the forward draft and this is aft draft. So let's work out what is going to be the correction. Well, the correction is going to be true trim into distance of center of flotation from midpoint divided by LBP. I can easily solve this equation to find out. Say for example, we have this small triangle here. Let me choose this color. This triangle, a small triangle. So this is the correction. So the correction divided by this distance, and let me use this word HF, where I use this F and H is the mid length, is equal to, now let's take the big triangle and let me mark here, this is A and this one I will mark as B and this one as C. So if I just draw this line like this, so this BC is LBP and A and B, this one is A and B, this is a true trim. That means this is the trim at forward draft mark and aft, this is the trim at forward perpendicular and aft perpendicular. So we will write like this, true trim divided by LBP. So this way it will give me the formula that correction is nothing but true trim into HF. Let's go here. The correction is true trim into distance of center of flotation from midpoint divided by LBP. Now, in our example, we had these drafts at perpendicular. The forward was 5.18, midship was 5.73 and aft was 6.24. Okay, so let's find the true trim. True trim is the difference of forward draft and aft draft at perpendicular. So this is 1.06 meter by astern. Now, means of mean draft, which we had taken F plus A plus 6 into midship draft divided by 8. So we have this draft 5.725. Actually, this draft is almost close to draft at mid length. Now, let's see what is the LCF. If we enter with this draft 5.725, which is almost 3/4 of the midship draft and 1/4 is of the mean draft, which is very close, and we get this value. Let us find the distance of mid length. So LBP was 106. So let me mark here, say A and B. So the total distance was 106 meter and H is the mid length. So LBP by 2 is 53. That is AH. And the LCF, that is the center of flotation, is a 52. First let me mark here, this is 53, and the LCF, that is a center of flotation, is 52. So this is F and this is H. We can say that HF is 1 meter aft of midship. So this is 1 meter and this is aft of midship, that is 1 meter here, this distance. Now let us find out the correction. The correction is going to be 1.06, that is true trim, into 1 divided by 106, or simply 0.01 meter. So let's find the true mean draft. The true mean draft will be 5.725. That was the means of mean draft which we had calculated by using the formula for Hogg and Sag, and we add this 0.01 to get 5.726. Well, let me clarify why we need to add. If we look at here, the vessel is trimmed by a stern. This is your stern trim. So, and the center of flotation is close to aft. So this needs to be added, and the correction needs to be added is this one. This is your mid draft. So I need to add some correction to obtain the draft at center of flotation, this draft. The simple rule is that this correction is added, that is positive, if COF is closer to the end which she is trimmed. So if it is trimmed by a stern and it is closer to the aft end, then this correction needs to be added. Well, this draft is a TMD, that is true mean draft, and it is based on some assumption that the ship trims about a fixed point. That means the center of flotation is constant. However, center of flotation also changes with the ship's trims, and we need to apply the second correction for trim also.